Alright, this is Algebra 1, Chapter 11, Section 2, multiplying and dividing rational expressions. And we have two purposes here, two objectives. The first one is to multiply and divide rational expressions, and the second is to be able to simplify complex fractions. You guys are in charge of all this information here. And definitely the learning objective. Alright, so we're going to look at a couple of examples. Please do not write these down because I want to do, we're going to do our own examples. But I want you to see it first. So, problem number 1A has two items being multiplied. We have a 6 over a squared and times negative 2 over a to the third. So what you do is, just like multiplying fractions of numbers, you multiply the tops together. So in this case it would be 6 times negative 2, and multiply the bottoms together. The hardest part of this is remembering when you have exponents, you add the exponents together. So in this case we get negative 12 over a to the fifth. And because a is in the denominator, we have to say not equal to 0 because we can't have a denominator equal to 0. In a more complex problem, if I have x minus 7 over x times x minus 5 over x plus 3, the tops get multiplied together and the bottoms get multiplied together. We can leave the product in factored form. We don't have to multiply everything through. So writing it just as x minus 7 times x minus 5 over x times x plus 3. And then we have to exclude our denominator equal to 0. So x can equal to 0 and x cannot equal negative 3. So now this is what I want you guys to write. We're going to do these two problems together. What is the product? State any excluded values. So we are going to rewrite this as the tops multiplied together and the bottoms multiplied together. 5 times 3 is 15, and y to the 1 times y to the third is y to the 1 plus 3, or y to the fourth, and we definitely cannot have y equaling 0. Alright, so for B, we have the tops multiplied together and the bottoms multiplied together. Now I need to exclude any values, and I just want to take the opposite of whatever numbers I have next to my x. So the opposite of minus 2 is plus 2. And the opposite of minus 3 is plus 3. So x cannot equal 2 or 3. And just all that is minus. So let's get a little crazier up in here. Now I have a couple things that need to be factored. My tops, I'm still going to use the same process. I'm going to multiply the tops and multiply the bottoms. But if you look here where I have 7x minus 21. You guys do not have to write these down. We're just looking at it. I have a 7 that I can factor out, and then I'm left with an x minus 3. And then x squared plus 3x minus 10. And once again, you can use what's in the opposite numerator or denominator. So I'm in the denominator, so I'm going to look at my numerator. If I want stuff to cancel out, I have to have something that's an x plus 5. So in fact, one of the factors of x squared plus 3x minus 10 is x plus 5. So two numbers that multiply to give you negative 10 and add to give you 3 are 5 and negative 2. So once we do that, all the tops get multiplied together and all the bottoms get multiplied together. And then you can cancel out. So this x plus 5 and this x plus 5 divide out to give you 1. this 7 and 14. 7 goes into both of them. It goes into this bottom one once and into the 14 twice. So once I have those, I know I have 2x for the top and an x minus 3 and an x minus 2 on the bottom. All right, so let's do a little practice problem. So I get 3x squared and an x plus 2 on the bottom. And my x squared plus 3x plus 2 is going to factor out. I need a value that multiplies to give you 2 and adds to give you 3. So that is 1 and 2. And I know that if x plus 2 divided by x plus 2 is 1. And 1x on the bottom here cancels out with one of these x's here. So I'm left with 3x times x plus 1. It's over 1 because these guys just become 1. And that's it. That's for A. B says, in problem 2, suppose you multiply the numerators and denominators before you factor. Will you still get the same product? Explain. And the answer is yes, but it is more complicated. Yes, but then you'll have to factor the products and it takes longer. It's actually more efficient to factor it before you multiply. Alright, so let's do A together. So we want to factor first. So 2x minus 14 has a 2 that we can factor out. And 4x minus 6 also has a 2 that we can factor out. Six x squared minus 13x plus 6. I bet you one of its factors is 2x minus 3. And that would leave us with 3x minus 2. And I'm going to FOIL it just to double check that I have the right value. 2x times 3x is 6x squared. You guys don't have to write this down. This is just my double check. Minus 9x plus 6. This does give me 13x, 6, and 6x squared. So I like this system because you can actually use the values they give you to figure out what you have to factor for. All right, and this is all over 1. So now let's 2x minus 3 and 2x minus 3 cancel each other out to give us 1. And the 2 and the 2. So we have x minus 7, 3x minus 2, and that is our answer.
It's actually easier than it looks.
Yeah. Okay. Now, dividing is the same as multiplying, except remember when you divide by a fraction, you multiply by the reciprocal. So if we look at our sample problem, they had x squared minus 25 over 4x plus 28 divided by x minus 5 over x squared plus 9x plus 14. So you start out with that on your paper. The first item stays exactly the same, and the second item flips, so you have the reciprocal, and this divided changes to a times. Then we factor everything out, and then we cancel our like items, so we get 1, and then we rewrite our simplified version. So let's try that with a couple of these problems. Our first one, we're going to rewrite the first item. We're going to write multiply instead of divide, and we're going to go reciprocal. My x plus y divided by x plus y is going to give me a 1, and my 1x here divided by my 1x here is going to also give me a 1. So I will end up with 1 over 1. Let's get a little bit more complicated here. So we rewrite the first item. Write a multiply instead of a divide, and then flip. Now we follow the same process where we factor. So I'm going to factor a 4 out of here. I'm going to factor a 2 out of here. I'm going to factor a 3 out of here. And I'm going to factor this guy. I need two numbers that multiply to give us 8 and add to give us 6. I believe 2 and 4 are my winners. So now is my favorite part, where we cancel everything out. And everybody lives happily ever after. K plus 2 and k plus 2. 4 divided by 2 is 2, and 2 divided by 2 is 1. I think that's 2 times 3 times 1, and that's 1 times k plus 4. Woohoo! All right, so now we're going to apply this to complex fractions. So go ahead and write down a complex fraction. It is a fraction that contains one or more fractions in its numerator, in its denominator, or in both. You can simplify a complex fraction by dividing its numerator by its denominator. And I like to think of it as, I'm going to rewrite it using division. So if I look at my sample problem here, I get 1 over q plus 4 divided by 2q squared over 2q plus 8. It's 1 over q plus 4 times 2q plus 8, the reciprocal, over 2q squared. So once we have it written, so we rewrite the problem as a division problem instead of a fraction. And then once we have it as a division problem, we write it as a multiplication problem with the reciprocal. And now let's factor. 1 over 2 plus 4 times, I'm going to factor out a 2 from the 2q and the 8. And this is 2q squared. The q plus 4 divides with the q plus 4 and gives us 1. The 2 divides with the 2 to give us 1. So we are left with 1 times 1 times 1 on the top. And we are left with q squared in the denominator.